Welcome to our TSI math test presentation. The purpose of this presentation is to review several types of problems that you could encounter on the test. My name is Alan Beekman, a math coach here at the University Park campus. Here's a list of the topics that will be covered in the presentation. I'll share a list of math topics that you may encounter on the test. Then I'll work through 8 sample math problems, and I'll end with a brief discussion of ways that you can find help here at University Park. The test will focus on questions that can be categorized into the 4 areas shown on this slide: elementary algebra, intermediate algebra, geometry, and statistics and probability. As you study for the exam, keep in mind that the questions may come from any of these areas. If any of these subtopics are known to be difficult for you, it would be good to put in some additional study time in that area. I'll discuss some ways to get additional help later in this presentation. So let's dive into a few problems. As a math coach, I hear a lot of students talk about how they hate fractions. The real difficulty is that they often don't remember the rules. And that's why I chose this particular problem. It requires working through several of these critical rules for fractions. As you can see, if fractions scare you, this problem might look intimidating. So let's take it step by step. So the question is, what is the solution to the equation 1/2 x plus 3/2 times the quantity of x plus 1 minus 1/4 equals 5? The first step is to work through the parentheses, distributing the 3/2 to the quantity x plus 1. So you can see when we do this, we get 1/2 x plus 3/2 x plus 3/2 minus 1/4 equals 5. Next, we'll combine like terms. So we have the 1/2 x plus 3/2 x, so we'll take out the x, which is a common term, and we have 1/2 plus 3/2 times x. And then we have the two constants, 3/2 minus 1/4. Now we need to resolve those fractions. So we have the 1/2 plus 3/2, that's going to give you 4/2, and that by itself is going to resolve down to 2x. Meanwhile, with the constants, 3/2 minus 1/4, we need to find a common denominator. So when you're adding or subtracting fractions, you need to have a common denominator. Looking at the denominators here of these two, we have a 2 and a 4. So you can see that if we multiply the 2 by 2, we're going to get a 4, and we'll have a common number 4 in the denominators. Well, if we're going to multiply the denominator by 2, we also need to multiply the numerator by 2. So that would give us, when we take 3/2, we multiply the top and the bottom by 2, and that's going to give us 6/4. So we'll end up with 6/4 minus 1/4, and when we add or subtract fractions and we have a common denominator, we simply do the operation in the numerator. In this case, 6 minus 1 over 4, or 5/4. So now we have 2x plus 5/4 equals 5. The next thing we want to do is move all the constants over to the right side of the equal sign. When we do that, we have 5 minus 5/4. And now we need to resolve that right side. So once again, we have a number. This time we have a whole number minus a fraction. Once again, we need to get a common denominator. So what we do is think of the 5 as 5 over 1 as a fraction. And now we have a 1 in the denominator and a 4 in the denominator. So we're going to multiply the numerator and the denominator of the 5 by 4 to get it into fourths. When we do this, we end up with 20, 5 times 4, and we have 20/4 minus 5/4, or again, 20 minus 5 in the numerator over 4 in the denominator equals 15/4. So the last step will now be to divide by 2 to get rid of the 2 on the left side. When we divide the 15/4 by 2, we have to remember now a new rule for math, and that is that when you divide a fraction by a fraction, you flip the bottom fraction, the denominator, and multiply. Well, 2 doesn't look like a fraction, but once again, we're going to make it 2 over 1 to make it into a fraction. So when we flip that, we get 15/4 times 1 over 2. And again, when you multiply fractions, you multiply the numerators, you multiply the denominators. That gives us 15 over 8. The answer, C. In this next problem, we'll work through an inequality along with using another fraction. Notice that when we begin with a greater than or equal to sign. So it says, which of the following inequalities is equivalent to 3 minus 1/2 x greater than or equal to 2? Since we're looking to solve for the variable x, the first step is to move the constant 3 to the other side of the equal sign as we attempt to isolate the x. So we're subtracting 3 from both the left and the right side. That gets rid of it on the left, and we have minus 1/2 x greater than or equal to minus 1. Next, we're going to divide by negative 1/2 to get rid of the negative 1/2 on the left. But when we do this, the key rule here is that when you divide or multiply by a negative number, you have to flip the inequality sign. So we started with a greater than or equal to, and when we do the division by a negative number, we're going to flip that to a less than or equal to. It gets rid of the negative 1/2 on the left, so we just have x. And on the right side, we're dividing negative 1 by negative 1/2. Again, we're dividing a fraction by a fraction, so we take the fraction in the denominator, negative 1/2, and we flip it and multiply. So that gives us negative 1 times negative 2 over 1. And that's, since we have two negatives, that equals a positive when we multiply, and it gives us equal to 2. So that leaves the equation, the inequality, as x less than or equal to 2, which is answer B. The next problem requires that you remember a couple relatively simple formulas, both the area of a circle and that of a square. Don't get bent out of shape over the strangeness of the potential answers. So let's take a look at this. When you look at this, the square and circle, you can see that the radius is marked in red here on the circle, and it makes sense then that the length and the width of the square are both 2 times that radius. So when we think of the formulas, the area of the square is simply the length times the width. Well, if the length and the width are both 2 times the radius, then we have 2 times the radius times 2 times the radius, which is 4 times the radius squared. The area of a circle, of course, is pi r squared. Now to find the shaded area, because we're looking at the area of the shaded region, we want to create the equation of the shaded area, and that's going to be the area of the square minus the area of the circle. In other words, 4r squared minus pi r squared. Well, that isn't one of the answers in the A, B, C, D list, so we need to look at this a little further. We can simplify this by pulling out the common factor of r squared. And when we do this, we end up with the quantity 4 minus pi times r squared. And that is answer C. Next, we'll look at a word problem that requires setting up equivalent ratios. This means that we compare amounts of 2 different types of units in a sample case to determine the amount in a second case. To do this, we first need to identify the given ratio. When we look at the problem, we see that Jacoby followed a recipe that required 2 cups of water for every 3 cups of flour. That's the given ratio. And then it says if he used 8 cups of flour, how many cups of water did he use? So we set up this equivalency statement that says 2 cups of water over 3 cups of flour equals x cups of water over 8 cups of flour, the x being the number that we want to find. Now, it's important that when you set up this kind of statement, that you have the same units in the numerator and the same units in the denominators of the two ratios. So 2 cups of water to 3 cups of flour was given. We're trying to find the cups of water when we use 8 cups of flour. We need to establish that similar ratio and set the ratios equal to each other. And again, the key is that you ensure the same units are in the numerators and denominators. And note that it's easier if you place the unknown value in one of the numerators. You can do it if it's in the denominator, it's just a little easier if it's in the numerator. So to solve this problem, we simply multiply by the 8 in the denominator, and we get 2 times 8 divided by 3, which is 16/3. Now, to simplify 16/3, you divide 16 by 3 and get 5, and you have a remainder of 1, which leaves it as 5 1/3 cups of water. And that's answer C. Now let's look at a problem that deals with exponents. As with fractions, there are specific rules you need to remember to solve exponential problems. The question is, which of the following values is equivalent to 5 to the -3rd power? To solve this problem, we need to remember one of the more obscure rules, and that is negative exponents. So when you have a negative exponent, here we have a to the -x, a being any number, and the exponent being a negative number, that's equal to 1 divided by a to the positive x. So and likewise, if you have a negative exponent in the denominator, you can flip that to the numerator and make it a positive number. So the rule of negative exponents is that if you have a negative, you move it between the numerator and denominator to make it positive. So in this case, let's calculate the value. 5 to the -3rd power equals 1 over 5 to the positive 3rd power, which is the same as 1 over 5 times 5 times 5. That's 5 to the 3rd power, and that's equal to 1 over 125. The answer is B. In this next word problem, we investigate sums and averages of numbers. Word problems can be tricky, so you need to read the words carefully to properly interpret what needs to be done. In this case, it says 5 of 6 numbers have a sum of 25. The average of all 6 numbers is 6. So what is the 6th number? This one actually is relatively simple once you understand that question. So first we want to calculate the total of all 6 numbers. The average is 6. So if we have 6 numbers with an average of 6, we're going to multiply those together, 6 times 6. So the total of all 6 numbers is 36. Now we're given the fact that the 5 of the 6 numbers have a sum of 25. So we're going to subtract the total of the 6 numbers minus the total of 5 numbers, which is 36, minus the 25, and that gives us the 6th number of 11, which is answer C. Set theory can be a bit difficult at times because it doesn't necessarily involve calculating numbers. Simply stated, sets are simply groups of items, whether the items are numbers, letters, or even articles of clothing. In this problem, you're going to need to understand the U-shaped symbol and also the upside down U. The U stands for union, and the upside down U means intersection. I'll explain more about these as we work through the problem. So let's take a look at the problem. Sets L, M, and N are shown below, and we see them here in green, purple, and pink. So the set L contains the numbers 0, 20, 40, 80, and 100. M contains 5, 10, 15, 20, and 25, and N, you can see, has 10, 20, 30, 40, 50. So it says, which of the following sets represents the set L in union with the quantity of set M intersected with set N? So the first step here is to do what's inside the parentheses, and that is set M intersected with set N. So intersection, when you look at sets, means that the number has to be in both of the sets to be part of the intersection. If we look at M and N, M has the numbers 5, 10, 15, 20, 25, and N 10, 20, 30, 40, 50. The only numbers that are in both sets are the 10 and the 20. So that's the intersection between set M and set N. Now the next thing we need to do is this union between set L and what we just calculated in step 1, the intersection of M and N. So L has 0, 20, 40, 80, and 100, and M intersected with N has 10 and 20. Well, union means that the number can be in either of the sets. It's kind of like an OR. It can be in L or in this intersection of M and N. So when we look at this, L has 0, so that's included. M intersected with N has a 10, so we're going to include that. Both sets have a 20, so that gets included. And then the other numbers in set L, 40, 80, and 100. So the result of that is this list here with all of those numbers, and that is answer B. A system of equations problem involves two or more equations, each with two or more variables. Here we have two equations with two variables or unknowns called x and y. So the question is, what is the solution to the following system of equations? And we have x squared minus 2x plus y equals 8, and a simpler equation, x minus y equals negative 2. There are actually several methods to approach solving a system of equations. Two of these methods are called elimination and substitution. For this final sample problem, we're going to utilize the substitution method. And you can see that we could easily take this second equation, x minus y equals minus 2, and utilize the substitution method by setting it equal to just y. So the first step is to manipulate that second equation. X minus y equals minus 2. We subtract x from both sides, and we end up with negative y equals negative 2 minus x. Well, we don't want negative y equal to something, we want positive y. So a simple way to resolve this is to multiply both sides by negative 1. We multiply negative y times negative 1, we get positive y. We multiply negative 2 minus x on the right-hand side of the equation by negative 1, and it simply flips the signs to positives. So we get y equals 2 plus x, which is the same as x plus 2. Now we can substitute for the y in the first equation and factor out the equation. So we have x squared minus 2x, and we're going to substitute for y the x plus 2 equals 8. Then we put the common terms together, and we subtract the 8 from the right side and move it to the left side of the equal sign because we want to set this equal to 0. So that gives us x squared plus negative 2x plus x plus 2 minus 8 equals 8 minus 8, or 0. That's going to leave us with x squared minus x minus 6. Now, why did we set it to 0? It's important when you have an x squared, a quadratic equation, that you set these equal to 0 so that you can factor the equation. So we have x squared minus x minus 6, and we need to find two factors that multiply to negative 6 and add up to the negative 1 that's on the x. And we find that with negative 3 and positive 2, we meet that criteria. So that leaves us with the quantity of x minus 3 times the quantity of x plus 2 equals 0. So next we need to determine the solutions. So first we find the x values using the two terms x minus 3 and x plus 2, and we set each one of those equal to 0. So if x minus 3 is equal to 0, then x is equal to 3, and if x plus 2 is equal to 0, then x is equal to minus 2. Next we find the y values associated with those x values. If x is equal to 3, then we'll substitute that 3 back into one of the equations, and we'll take the simple one, x minus y equals minus 2. Substituting in a 3, we get 3 minus y equals minus 2, thus y is equal to 5. And if x is equal to negative 2, then negative 2 minus y equals negative 2, and y is equal to 0. From this, we see the solutions are 3, 5, x equals 3, y equals 5, and x equals minus 2, y equals 0. And that is answer D. So there are several ways to get additional help when you're preparing for the TSI math exam. We have 2 physical locations here at the University Park campus. The Math and Science Lab, which is on the 8th floor in the library, and the Math Hotspot, which is on the 3rd floor. Both of these provide drop-in help, free of charge, for any level of math, and TSI included. If you try one area and it doesn't suit you, you can try the other one. There are just some slight differences between the operations in the labs. You can click on these links to find more information about the schedule and when they're open and so forth, and additional information at our academic coaching website. In addition, our website provides a number of links to other websites, helpful videos, and information about the TSI test. This information includes several practice exams as well as numerous videos and other study materials. So if you click on this link here, Online TSI Resources, you'll find a page that's shown like this up in the upper right-hand corner. And there's just a lot of information about what the test is, and particularly learning resources. So that third link, TSIA Resources page from the College Board, an extensive list of content in there. And going back to the page where we looked at the topics and subtopics you may hit, when you go out to the College Board site, you can actually dig into that and specify which type of subtopic you want to look into. And you can find many videos and helpful tips on studying for that particular subtopic. So I hope that you found this video to be helpful, and I wish you good luck in your quest to pass the TSI math exam.